Hi students, welcome back to ChemOrgChem. So in this NEET Chemistry 360 series, we have been exploring the solution for previous year NEET Chemistry exam papers. If you are new here, don't forget to subscribe and hit the bell icon for notification. So let's see what's today's problem. So here today we are going to tackle a classic organic chemistry question that appeared in NEET 2022. So here is the question we will be working through. Which compound amongst the following is not aromatic compound? And we are given four cyclic structures labeled 1 to 4 and some with pi bonds and formal charges. So let's moving to the solution. To solve this, we need to remember the fundamental criteria for a compound to be considered aromatic. So let's see rules for aromaticity. The first rule is cyclic. The molecule must have a cyclic or a ring structure. The next rule is planar. The ring must be essentially planar, allowing for effective overlap of p orbitals. Next, moving on, conjugation. The ring must have a continuous system of overlapping p orbitals, usually involving alternating single and multiple bonds, or sometimes lone pairs or vacant orbitals in the ring. The final rule is Huckel rule. The cyclic conjugated system must contain 4n plus 2 pi electrons, where n should be an integer such as 0, 1, 2, etc. So let's analyze each of the given compounds step by step. So first moving on, our first option. So this one is a tropylium carbocation. First we should see this compound is cyclic or not. Yes, it is cyclic compound. Next we should see this compound is planar or not. Yes, this compound is planar. Since the system is conjugated system, so therefore it generally adopts a planar or near planar geometry. So next moving on, which is conjugated or not. Yes, which is conjugated, it has 6 delocalized pi electrons. We have alternating double and single bonds and the positive charge, which indicates that vacant p orbital that can participate in the delocalization. So it is fully conjugated system. So next moving on, our Huckel rule. So let's count the number of pi electrons present in this system. So there are 6 pi electrons are present in the system. So each double bond contributes 2 pi electrons. So we have 3 pi bonds. So therefore total 6 pi electrons using Huckel rule 4n plus 2 pi electrons, which is 4n plus 2 equal to 6. Then 4n equal to 6 minus 2. So when you move plus 2 to this side, that will get negative charge. So therefore 6 minus 2. So which gives us n equal to 1. So therefore this one is a integer. Therefore this system obeys Huckel rule. So based on that, this 4 rule, this compound is aromatic compound. Moving on, our second compound, so which is cyclopropynyl carbocation. So first we should see this compound is cyclic or not. Yes, this compound is cyclic compound. Our next rule is either this compound is planar or non-planar. So this is 3-membered rings having one alkene as well as one vacant p orbital. Therefore, this compound is planar compound. And next moving on, either this compound is conjugated or not. We have a double bond which contains 2 pi electrons and positive charge, indicating that a vacant p orbital on the carbon atom with the positive charge. So this vacant p orbital can participate in resonance with these pi electrons of the double bond, creating the conjugated system. Therefore this is fully conjugated. It has two delocalized pi electrons. So next moving on, Huckel rules. So we have two pi electrons from the double bond using Huckel rule 4n plus 2 equal to 2. So when you move this plus 2 this side, when you move this plus 2 this side, so now 4n equal to 2 minus 2, now n equal to 0, which is integer, hence this compound also aromatic compound. So let's moving on our third option. So according to our first rule, this compound is cyclic or not? Yes, this compound is cyclic, it is a ring. So next moving on, is it planar or not? No, this compound is not planar. Since this compound up to here having alternate double and single bond, however here you see it contains one CH2 group also. So therefore these three double bonds may be present in the planar. However, the CH2 group may not present in the planar shape because of this carbon has sp3 carbon. So remaining all these carbons are sp2 carbon. So therefore, this compound is not planar shape. And next moving on, conjugation. So this compound doesn't contains any conjugation. If it were planar, it would have a fully conjugated system of number of pi electrons. However, due to non-planar geometry, the p orbitals are not aligned for effective overlap and the conjugation is disturbed. Therefore, here no conjugation at all. Okay, let's moving on Huckel rule. So Huckel rule 4n plus 2 pi electrons. Here there are 6 pi electrons present in this compound. Therefore 4n plus 2 equal to 6 and 4n equal to 6 minus 2, which produce n equal to 1. It obeys Huckel rule. However, other criteria such as planarity as well as conjugation, so these two criteria not fulfilled. Therefore this compound not aromatic compound. So next moving on. So finally let's examine our option 4. So this is a 5-membered ring with two double bonds and one negative charge on the carbon atom. So first see, this is cyclic compound or not? Yes, it is a ring cyclic compound. Next moving on, is it planar or not? Yes, it is a planar. 5-membered ring with conjugated system tend to be planar or nearly planar. So next moving on, is it conjugation or not? It has 6 delocalized electrons. We have 2 double bonds which contains 4 pi electrons and negative charge which contribute 2 electrons. So this negative charge represents a lone pair of electrons in a p orbital which can participate in the delocalized pi system. So we have a continuous cycle of overlapping p orbital which makes that fully conjugated structure. So let's moving on our final one, Huckel's rule. So as per Huckel's rule, 4n plus 2 pi electron, here there are 6 electrons. So here you see this double bond contribute 2 electron and this double bond contribute 2 electron and this negative charge contribute 2 electron. Therefore total 6 electron. So 4n equal to 6 minus 2 which produce n equal to 1. It obeys the Huckel rule. Therefore this compound is aromatic compound. So let's moving to our question. So as per our discussion, among the 4 answer, the correct option for this question is option 3. I hope this explanation was clear and helpful. Remember the key criteria for aromaticity, especially Huckel role and the importance of planarity for continuous conjugation. If you have any question, feel free to leave them in the comments below. Don't forget to like this video and subscribe for more chemistry content like this. And finally, thanks for watching. I will see you in the next video. Bye bye.